Good day and welcome to this episode. We are still on vectors, and in the last episode we have been dealing with different topics. And this time we are going to be dealing with vectors components in unit vector terms. That's I, J, and K. And we are going to be dealing with magnitude vector. We have been used to this, and finally we come to directional cosines. So without wasting much of our time, let's dive into this. Now, vector components in unit vector terms. You know unit vectors as I, J, and K in the direction of X, Y, and Z respectively. So now, explaining this now, we have something like this. So I call this my Y axis, I call this my X, and I say this is my Z. Now, we have a vector OP. A vector OP in this way. Let's say this is OP, and this OP is also equals to R. That is maybe the resultant. So R. So now R will be the sum. What will give us R will be this direction plus this direction plus this direction. So I will denote them. I can say OX is A, and I will say OY is B. And I'll say OZ is C. Now, what are the components? OP in the direction of OX is A. Then OP in the direction of OY is B. Then OP in the direction of OZ is C. So now, when we are dealing with this, we just say OP is equals to R. Then we can say OP in X direction. This is direction. OP in X direction is A. Then OP in Y direction is B. Then OP in Z direction is C. That is here. So now we can have an equation that says that R equals to A plus B plus C. That is our vector OP, which is still our R. So as you can see, we can now include our unit vectors, which are the I, J, and K. So I will be for the vector, will be for the OX direction, J will be for the OY direction, and K will be for the OZ direction. So we have I, we have G, and we have K. So now if you want to write it in vectors form, you can have it as AI plus BG plus C. So this is vectors components in unit vector terms. This is the basic explanation for that. So we are going to be taking a few examples. Let's say we have question 1. We have Z1 as 2I plus 4J, and we have Z2 as 5I plus 2J. So, and we are asked to find Z1 plus Z2. Very simple. We are taking both I and both J. Then we asked to look for Z1 plus Z2. What's our Z1? This is we can bring it outside. Say 2I plus 4J close bracket, then plus we bring this here to 5I plus 2J. So now we now start taking the related unit vector together. So like that we'll be having 2 plus 5 here, which is 7I, then plus, and the 2 plus 5 here, then plus is here, so you have to put plus here. You have 4 plus 2, which is 6J. So that's for that. Let's take another example. We have another question 2. Let's say we have Z1 equals to 3I plus 2J, and Z2 as 4I plus 3G. Now we have to find Z2 minus Z1. Now how do you do this? Still the same process. Bring your z2, then minus, bring your z minus. So what's your z2? Your z2 is 4I plus 3j and minus 3I plus 2j. So now you can calculate further. So 4 minus 3 will be 1. That's 1I, which you can also write as I. So 4 minus 3. Then we have plus. Bring your plus here. Then 3 minus 2, which is also 1. So we write it as j. So our answer here is I plus j. So now we are dealing with magnitude of vectors. So when we are dealing with magnitude of vector, you have a formula for that. So we can say, example now, we have OP here, and we have a component of I, J, and K. That's the unit vector of the component ABC. So we can say OP, if OP is AI plus BJ plus CK, which is also our R. We can say the magnitude of OP, which is the magnitude of R, will be square root of A square plus B square plus C square. So that's the basic formula. Now we're going to take a question of that also. Let's say we have question 3. You are PQ. If PQ is 4I plus 3J plus 2K. So we have to find the magnitude. Find the magnitude of PQ. So it's very simple. You have your unit vector I, J, and K. So you have know the formula we are using here. So let's say A is 4 now, B is 3, and C is 2. C is 2 years. So we have the formula. Magnitude of PQ will be 4 square plus 3 square plus 2 square. So what will that give us? We are having 16 plus 9 plus 4. So what will that give us? We are having a root of 29. Yeah. So that's for that on this part. So we are going to be dealing with directional cosine now. So directional cosine. So this directional cosines, we also have another diagram that looks like this, but this time around, according to what we were given in our text, we are going to be using the 3 dimensions, and we are going to be considering the angles that the vector makes with each of those directions. So we have something like this. We are having still the same, yeah. So this time around, let this be our exercise. You can use any direction, but just to go along with the text, let's use this. So we have y here and we have x. So what do we do here? The x indicate the vector that we are using. So and it is still vector OP that we are considering. We have vector OP. Now this OP, we are going to be considering it. It's going to make an angle with these 3 directions. Okay, now let's say OP is R as usual now, and we say OX is A, then OY is B, then OZ is C. So we are going to be considering this vector OP. This is what we are concerned with. So we are considering the angle it makes with the 3 dimensions, with 3 directions rather. So now this OP now, what angle is it making with? Let's say is it here, and it's making, let's represent that as alpha. Now let's take OP and OY. What angle is it making with OY? It is making, let's use that one as beta. Then what angle is it making with OZ? Let's take that one as gamma. So now we can see that we've represented them. So we are going to be using trigonometric function of cos, because we are dealing with cosines here, as you can see, directional cosines. So we now define cos of each of those angles. Are we together? So now we say we have cos alpha, we do for cos beta, and we do for cos gamma. Now what is the formula for cos? We all know that back in our trigonometry, we know that cos theta is adjacent over hypotenuse. That's also tattoo. So you can now take each of those components together. You can see this OP and OX. If you take a line from here and join it here, you notice that this angle will be what? Will be opposite. That means the line here will be opposite. So and this line here is opposite, this one will be adjacent, and this will be the hypotenuse. So if this is the adjacent, that means cos alpha will be what? A over R. Do we get? So cos alpha will be what? A over R. So similarly, we have done for OP and OX. So now let's take OP and OY. Now this is the opposite. It's facing this place. So we can have an imaginary line here. If you have an imaginary line, that means this is the opposite, and this is the opposite. This will be the what? Adjacent, and this will be the hypotenuse. That means this is B over R. Similarly, take for OP and OZ. So if you have an imaginary line here also, this will be the opposite. Then C will be the adjacent, and this will be the hypotenuse. So you notice that C is equals to C over R will be equals to cos gamma. So you can rearrange it and make your A, B, C separate of the formula. So like that, we are having A is equals to R cos alpha, then B is equals to R cos beta, then C is equals to R cos gamma. Now remember the formula that we used here. We'll be having OP R squared. Now this is Pythagoras actually. A squared plus B squared plus C squared. Now how is it Pythagoras? If you check this stuff here, you can bring this line dotted down here. It's still the same C. Then if you bring this one parallel here, you see that it will cut like this A. If you cut like so, you're already having a triangle. And if you want to look for the Pythagoras theorem of triangle, you see that R squared is equals to A squared plus B squared plus C squared. I just never take into that, but this is what we are using. Now, R squared, we know our A to be what? R squared R cos theta. So, and you just square it, you are having R cos alpha all squared plus R cos beta all squared plus R cos gamma all squared. So as such, we'll be having R squared equals to R squared cos square alpha plus R squared cos square beta plus R squared cos square gamma. So now we are dividing all through by R squared. So if we divide all through by R squared, let's see what we have by R squared by R squared. You notice that this goes out with this goes out with this goes out with this goes out with this. What do we have left? We have 1 equals to cos square alpha plus cos square beta plus cos square gamma. Now we now take cos alpha, cos beta, and cos gamma as LMN respectively. That's where we have our directional cosines. So we are having, you see, let us make cos alpha, cos beta, and cos gamma be N, N, and N respectively. So in that case, we'll be having 1 equals to N squared. You know, it is cos alpha that will make N. So that square will still be there. Plus M squared plus N squared. So that is just the derivation for directional cosine. So let's take, and that means now this here will be our N. Like that now. You know, we represented it as cosine and cos alpha. So this is our N, this is our M, and this is our N. So that's in short. So now let's take a question on this. Just a brief one. I'll say find the directional cosine. Find the directional cosine. That is the element of vector R equals 3i plus minus 2g then plus 6k. Now, the first thing to do is to look for magnitude. We have to get the magnitude of this, and we don't have to look from that. We've done that before. So the magnitude will be root of 3 squared plus open bracket minus 2 squared plus 6 squared. So now we'll be having R is equals to root of 9 plus 4 plus 36, which should give us root of 49, I think, yes, 49, then equals 7. That is our magnitude of R. That's our magnitude of R. So we will now bring out the directional cosine variable, which is L. So our L is A over magnitude of R. A over magnitude of R. So with that we have M. Let's define for all actually. So B will be B over magnitude of R, then N will be B over magnitude of R. So and as such, and what's our A? Our A is 3, then over 7. That's for the A. Then our B is minus 2 over 7. Then our C is 6 over 7. So in case we were given out, just say that just in case we were given out, this will be our cos alpha. Then this will be our cos beta, and this will be our cos gamma. So these are the directional cosines of the vector R3I minus 2G plus 6. This is the end of this video. Do well to like, share, subscribe, and comment. We are still going to be doing more of these videos. God bless you.